Super.
Thank you.
Thanks. Just a quick disclaimer, I am German, so if you feel more comfortable to give feedback, questions, or comments in German, that's also fine. But I'm joined by my colleague who does not speak German, so we decided to try to do the presentation in English now. For the program overall, we are planning basically to do this in 3 parts. The first part will be an introduction, short lecture of MVRDV, the company that we work for, and the background from the initial Regionmaker that was proposed around 20 years ago, followed by case studies. So we don't have a Regionmaker 2.0. In a way, this is the beginning of thinking about a Regionmaker 2.0. But we have a lot of projects in the office that in some form touch upon themes that could be relevant here. In the second part of the session, Janka will go, I think, pretty deep into technical considerations of, probably you should introduce it better than me, I guess of digital modeling of systems. And then the third part, we're hoping to have some form of an experimental session together with all of you to react and see and to think how can we develop more nuanced approaches towards digital tools that can model regions or from the scale, I guess, of the interior to the planet. And yeah, as I said, we will showcase some of that. So very quick intro, MVRDV office that was founded in Rotterdam. We are based in Rotterdam. It's an architectural firm founded by Winnie Maas, Jacob van Rijs, and Nathalie de Vries. We had 250 people. I think that might be a bit outdated. It's more than 300 now, mainly architects and urbanists. Focused on architectural buildings. This is the Villa VPO, Hannover Expo Pavilion here in Germany that was built around 2000, around the time of the Regionmaker, or Silodam. But we also work on an urban scale, of course. We have an urbanist department. So this is a project we did in Seoul, which was a reactivation of a former Highline highway. And we do a lot of research. The Regionmaker is part of that. It's here. And we collaborate with universities for this. And all of this research is somewhere situated between technical approaches and quantitative modeling and systematic approaches, but then also has this component of speculation and visionary thinking in it. So we break our own methods to really project, I guess, in more radical and more free ways. Context of the two of us. We're part of a research and development group within MVRDV that's called MVRDV Next, New Experimental Technologies. We founded that around 5 years ago. And basically, we work with the design teams in all of our 4 offices worldwide on projects and develop custom workflows and solutions for that. And we also do standalone research and independent projects and collaborations with universities. We'll show some examples of that in a moment. So basically, if this is the portfolio of MVRDV, which you can kind of categorize into all of these different programs, we are working on the back ends of that. So we're working on processes, on nudging things, making things more efficient or optimized, and transferring knowledge basically from project to project. We develop and implement computational workflows, so we monitor projects and evaluate their performances. We rationalize designs and speed up processes. We also will go in depth on this project in a moment because it's relevant. And of course, we have an interest just in experimental technologies, see what's going on, and just try things and make sense of them. Going back to the original Regionmaker, was done 20 years ago. We thought it's better to let the original authors of the project speak because, of course, neither of us was there at the time. But what is interesting, I guess, about the project is that it was commissioned as a study for the region of RheinRuhr, and it is actually a software manual. It's quite radical, I guess, 20 years ago to see a book that is tries to imagine futures authored by architects and urbanists, but rather than drawing or sketching them, they propose a software, and the book, the publication, is a manual on how to use that software. So we have a short video now, because actually this project was part of an exhibition that we developed last year at the Neu Institute in Rotterdam, where they interviewed the original authors and software developers of this tool.
En ja, de versie die nu bij jullie staat, dat is er eentje die ook wel gemaakt is, een variant die gemaakt is om op een tentoonstelling te kunnen zetten waar bezoekers zelf een beetje mee kunnen spelen. En dat is dan de versie die was voor RheinRuhr City heette dat, meen ik, de tentoonstelling in Düsseldorf. Waar ook het boek Regionmaker bij hoorde. Dus dat is een versie, een paar jaar later dan de functiemixer. Je hebt natuurlijk ontzettend veel gebruik van software en databases binnen de architectuur en GIS-systemen enzovoort. Maar dat zijn toch vaak dan databases. Dus gewoon heel veel data die wordt opgeslagen. En dat is super handig natuurlijk en heel praktisch toepasbaar. En ik denk dat functiemixer een beetje een soort vreemde eend in de bijt is en altijd zal blijven. Als ik het algoritme dan opstart, dan krijg je eigenlijk ruis. Hij gaat willekeurig veranderingen aanbrengen. Maar omdat de ene verandering niet beter is dan de andere, is het zoals ruis op de tv, zeg maar. Zodra ik één zo'n parameter aanzet, bijvoorbeeld dat mensen wel eens bij het water zouden willen wonen. Relation waterfront. Dus rood zou dan dicht bij dat water willen komen. Nou, die zet ik aan. En dat gebeurt dus ook. Maar je kan bijvoorbeeld zeggen, nee, maar het is niet alleen dat water waar ze bij willen wonen, maar ook bij natuur. Dus die kan je erbij aanzetten. En dan krijg je situaties waarbij je inderdaad ook weer dat groen ook weer naar dat wonen toe trekt. Je plant eigenlijk niks, maar je stelt eisen aan het resultaat wat je zou willen hebben. We hebben verschillende zoom levels bij deze. Dus bijvoorbeeld, je kan natuurlijk net zo goed zeggen, we hebben het over heel Europa. In principe abstraheert het programma daarvan. Dus op dit niveau, en je wil dat alle mensen willen luxe bij het water wonen, dan krijg je dit. Een soort naïeve oplossing, maar het is wel wat je vraagt. Maar we hadden ook bijvoorbeeld op dit niveau, op een veel kleiner niveau en in 3D. Het is denk ik niet echt gebruikt als in de zin van dat dat er echt uitkomsten onmiddellijk zijn toegepast of zo. Het is meer gebruikt als een soort ideeëngenerator. En ook wel gewoon bedenken van als je iets probeert te bereiken, als je eisen stelt aan een plan en je hebt een algoritme wat dat gewoon rukzichtloos uitvoert, wat komt daar dan uit?
Nou, wat je dus zag is dat er extremen uitkwamen. Of hele expliciete van, wat is dit? En op dat moment moet je dus een dialoog hebben. Dus het is bij ons echt altijd, we genereren die varianten met als doel om de dialoog op te starten. Van kijk, het is mogelijk. Dat zou dit opleveren. Dat was een soort nooit gedachte oplossing. Willen we dat ook? En wat zou dat betekenen als we dat echt zo zouden maken? Dus het is een echt onderdeel van dat wij altijd graag modellen en varianten ontwikkelden. Dat we heel graag de complexiteit van onze tijd willen opnemen in onze ontwerp. Omdat we denken dat daar ook mogelijkheden door ontstaan. Het is vrijwel altijd overtuigen om iets dichter te gaan en te stapelen. Met als nobel doel om ook ruimte te laten. Of iets open te maken. Dus dat hele gesprek, dat zie je eigenlijk in de loop van de jaren in allerlei varianten terugkomen. Ja, eerst heel primitief in tekeningen, maquettes, modellen. En die modellen worden alras vervangen door computermodellen en variaties. En een gesprek over wat zijn dan de relevante variabelen die je kunt inbrengen in een ontwerpproces.
So what we can see already is that as designers, of course, we tend to skip the step of analysis and understanding a place, and you immediately go into making and into seeing what happens and testing scenarios and evaluating them and so on. So when this was made 20 years ago, as we said in the introduction, it was radical. I think not many architecture offices would propose projects as software. But now, 20 years later, we see this every day. We see startups like Sidewalk Labs Delft, so it's a sub-company of Google that automates to a large part design and urban planning constraints and basically changes the role of a designer to choosing priorities, to changing numbers. Autodesk is doing similar things with automation and basically bringing design software into online platforms. And I guess these tools, like we see, we're confronted now with a landscape of tools that emerge and disappear daily, new plugins, new software. And in a way, basically the frameworks with which we make these tools have changed dramatically. So these are some of the software that we are also working with in the office. And basically they enable everyone to become the maker of tools. Any designer or architect with a basic knowledge of programming can make functional tools today. So the discourse of what a tool is and how it works is becoming a lot more nuanced. Instead of one region maker, one vision that needs a software development team, architects and designers, the two of us could make 3 in a day, more or less, or sketch out 3. And that's basically the goal also of what we want to do today, to sketch out different directions or different visions of like what kind of tools can we imagine together. Maybe it's not just one, but we need different region makers. So as this landscape of digital tools grows, also so does their agency. So also as designers, we see that now this design decisions with different stakeholders, from public stakeholders to developers to policymakers, are informed to a very large part on numerical outputs and on the results of simulations in digital tools. So the question then is, how do we position our tools? This is, we had some calls in advance together with Janka, and we tried to come up with some form of lenses or categories, different directions in which we could define design tools. So top-down versus bottom-up, centralized versus decentralized, modular systems or modular tools that are flexible and adaptable versus holistic ones, and so on. I think we'll go through that a bit later in detail. It's your part, actually.
Organic transition. So basically when developing this framework, we were also thinking that could we somehow visualize it? So could we attach some kind of pictograms to these words to enable us to not only describe new tools through text, but also maybe through images or through some kind of conceptual diagrams. So for example, you could see how regional and global are illustrated, but also all the other ones. So the entire, let's say, collection of these 10 opposites also get pictograms, corresponding ones, which can then be used to describe the tools we make or we propose or we want. So both for our tools, but as well as potential new region makers. So, and that's what we're going to try to do now in a bit of an experimental way, is to kind of try to, let's say, describe some of our projects, let's say, through some of the lenses of these opposites that we just shown. So starting with SolarScape, which is a simulation and negotiation tool for urban performances. Let's say we could try to classify it, or let's say the most dominant aspects of it are that it's exploratory, very regional, and univariate. And so what does that mean? Let's say I'm going to try to explain it through the project itself. So SolarScape is, let's say, a research project done by MVRDV Next, and it was initiated through, let's say, an internal need in the office to design with sun, or let's say with solar impact. And it's a research project that develops a computational model of the city of Rotterdam that visualizes public daylight policy. So it's extremely specific into this one parameter of sun, let's say, or sunlight or daylight on the region of Rotterdam and its context and its, let's say, kind of legislative situation regarding sun. So I think this is not displaying. There's an image here. Sorry, the dynamic diagram. So basically, what the tool tries to explore is the change from absolute envelope constraints to performative constraints. So, for example, as in urban planning, traditionally it would be done that a city would define absolute constraints as in, let's say, how high a building can be according to the context around it, minimum offsets from surrounding buildings, etc. Whereas an alternative way of doing it would be to define it performatively. So, for example, to say a certain area needs a certain solar exposure, and apart from that, you're allowed to build anything, how high, how wide you want, as long as those conditions remain within the parameters that you set. So, as these policies are becoming more and more complex, the question is, how can we understand the impact of these policies and these constraints? And basically, we took Rotterdam as an example because the center of Rotterdam has been defined in the form of a few high-rise zones, whose urban legislation in relation to density has already slightly changed towards performative constraints, in the sense that there is a maximum height limit of 300 meters, which is extremely high, but then there is a set of sunspots defined, which are kind of important public spaces throughout the city, which have specific daylight requirements or sunlight requirements attached to them. And the question is, how do these sunspots, together with the requirements, how do they impact space and what is possible in the city? So what's the possibility space? So what we designed is, let's say, a methodology which analyzes each individual plot, extrudes it into a series of, let's say, voxels, takes the corresponding or the neighboring sunspots, and evaluates each, let's say, cube voxel in that envelope to see if it obstructs the existing sunspot or not. And if it does, it removes it from the envelope because it is essentially unfeasible. And what this results when you apply it to the entire city is that you can transform these kind of maximum envelopes into very specific contextualized envelopes of possibilities defined by these sunspots, so by these performative constraints. And these are also, apart from being, let's say, a visualization of the policies, they are also envelopes for development opportunities in a city where sunlight can be the main priority. That's also, for example, why I would describe this project as, let's say, univariate, because it really focuses on this one parameter very intensely. And let's say this kind of methodology, if applied in the real world, it would really help in fostering and establishing a dialogue between the city and the entrepreneurs in a way to help both see what works best and to create a city that we all want to live in. Like I said, it can basically be interpreted as development potential sites for developers, as well as for citizens and municipality employees. It can help to visualize the impact of the policies that they're defining. So how could my city look like if these policies came to be and the city materialized in that way? So these are just a couple of examples of how Rotterdam would be transformed from, let's say, before and after if these envelopes were built to their maximum capacity. So the next project is Roofscape, which is, let's say, explores urban densification through rooftop intensification. And you could describe it as very data-driven, predictive, and modular, above all. So Roofscape explores Rotterdam again with, this is a project developed in conjunction with the Rotterdam municipality. It's actually currently in the process of being developed as an actual tool. And it explores, let's say, if the city of Rotterdam has certain ambitions as to what we want as a city. Let's say we want to be adapted for the climate, we want to generate our own energy, green spaces, more densification and housing, etc. And we have a lot of rooftops of different shapes, different sizes, in different locations. What can we place on these rooftops regarding the different programs that we would want? So, for example, social or green, energy, housing, or even mobility. And basically, we developed a framework which takes the rooftops itself, so the current situation of the city, as well as our desires, we could say our necessities of how much of something we need, and first quantifies all of the rooftops, as in their parameters, for example, size and slope, ownership, etc. Then combines those properties to evaluate each individual rooftop for viability for these individual programs, as well as then combining that with our wishes to generate scenarios of what is possible on those rooftops, and then quantifying that back into tangible impact. For example, you could imagine CO2 or the amount of energy you could produce with these interventions, etc. So on a more kind of specific example, you could take the city of Rotterdam, extract its rooftops, evaluate them according to different parameters, for example, height, sun hours, view quality, etc. You would get a map of the properties of these rooftops, which you could then combine in different ways according to the requirements of different programs to get maps of feasibility. So you could say the very dark red rooftops are very appropriate for social spaces, whereas light ones, not that much. And you could do this for every program, and in the end use this as data to generate scenarios which are viable on these rooftops. And that's, for example, why you could say that this project is extremely data-driven, because it really uses the existing data both on a GIS level, on an administrative level, as well as on a spatial level, because a lot of it is derived from the actual 3D model of Rotterdam, and kind of tries to project or predict possible outcomes for the roofscape of Rotterdam. And like I said, currently this is being developed in Unity into an actual functioning tool for the Rotterdam municipality, and we are anticipating that the first phase will be finished quite soon. And the result could be, of course, a city where rooftops become more than just empty space, but they become livable space, which contributes to the complete landscape of the city. The green dip, which you could say is data-driven, projective, and static, is a project developed by the Y Factory, which is, let's say, the research, research department connected to MVRDV at TU Delft. Is that an okay way to describe it? Yeah. And it explores the potential of greening our cities radically. So going from what is now to how much could we green and how could we green it and what would the impact be. So, and this is a completely speculative tool which is based on real data, for example, analyzing plans and the requirements to develop a speculative interface where you could define your needs and the location of the location where you're operating in and what the requirements of that location are. You could get a selection of possible tree species, inspect the individual species for their requirements and the benefits they bring to your environment. You could then define different building elements on which these, let's say, green plants and other greenery would be placed. Furthermore, you can also define how this is then placed on buildings in the city. And then when you kind of combine all of this together, you can take in existing cities and start testing scenarios on how you could greenify them. So for example, here you could say that every building gets a green hat. And not only that, you can also get some kind of immediate feedback on what that would mean. What would the impact of that be? So for example, you could say how much energy from biomass could be produced, how much wood could we produce, what would the average temperature reduction be, etc. And the tool, I think the strong point of the tool is that it really allows you to explore, anyone really, you don't need any expertise, to explore what your city could be through greening and what would that mean. And you can really take it very radically to the point where the entire city becomes an urban jungle. And this is just a quick fly through of a couple of cities where this was applied and the kind of, let's say, very extreme conditions that occur when a city becomes an urban jungle. Now, of course, you could say some of this is extrapolated to the kind of complete end, but I think the methodology and the speculation in the tool, which allows to generate or project, is a projective tool that generates new scenarios and possibilities, but it's still kind of derived from and is based on some scientific data on what these plants need and require, even though the final outcome is, you could say, very, very radical and maybe unfeasible.
I guess, yeah. I mean, I guess like it also shows already very maybe obviously one big shift from the old RegionMaker to today, that all of these tools are heavily focused also on how they visualize data and information rather than this 2D pixelated stuff. It's also, there's a strong component of making interactive tools to include more people in a way to be participatory and also suggest how the spatial consequences of the decisions that will be articulated in the form of sliders and changes of parameters. So those three projects now were research projects, either by the Y Factory or coordinated by us. This one is actually a competition entry by MVRDV, where we collaborated with the urban department for a competition in Hamburg. A master plan, the brief was a master plan for 20 years development, and I guess what we were interested in, it already had a 2-year participation phase, and we were interested in two things, like one, how to continue the participation of the inhabitants of Hamburg, and second, how to design a master plan in a way that it is flexible and adaptable to change, because how can we foresee what kind of city we need in 15 years from now? So we called it a serious game. This is the final result that was produced, and basically this is a non-functional software. It was a proposal for a software that we wanted to develop in case we would have won the competition, which we didn't. Which basically had two components. The first one is, I guess, like in some form, the expertise of an architect and or a planner, where you would define green spaces in the site, you would define public activators, and this is the part that anyone could play. So you could generate a lot of different scenarios. Everyone can make their own, place libraries and parks and infrastructure. And then the second part that we saw just flipping by then is an automated process of an algorithm that will densify this to create a business case and a city that is intense enough, I guess, to become feasible. So it's like really about this interaction of the decisions that you take consciously by placing activators in public spaces, and then the reaction of this algorithm. And we conceived it as a multiplayer game, so anyone should be able to access and create their own cities in it. And then there was an idea to correlate all of those, weigh them, and discover trends, I guess, and priorities within this. It makes sense maybe for a moment to dive into this, because I think it's a methodology that was to some extent applied already in the original Regionmaker and is still used in many of the tools that also Jaka showed before, which basically condenses different data sets. So on the left we see here, for instance, environmental parameters such as noise, existing building footprints, public transport radii, and so on. All of these as base maps, so as information about a city, which then get correlated in some form to talk about either potentials for housing or biodiversity, feasibility for office buildings. So in a way, these tools create profiles for different urban programs in what kind of environmental conditions they need. So basically the weighting of these base maps creates heat maps for locations in cities, and I think this is a system that you can use in 2D in the larger scales in regional planning and urban planning, but that we also apply in 3D, for example, in the SolarScape model that we saw earlier. So in this case, the tool has a very strong architectural design component, which is a catalog here of activators. So what you see on the left side are these elements that can be placed by users of the tool. And on the right side, the things that get automatically placed by the algorithm, so the densification. Yeah, I think this slide is in the wrong place, but basically this was the inspiration for that project. It's an experiment by Reddit, but I think given the time, we'll just skip that. It's called R-Place. If you haven't seen it, it's a fantastic video. But I think we'll just move on. This project, actually, we were not involved in. We just wanted to show it because it's an ongoing research or design commission by MVRDV, developed by our urban team, which investigates scenarios for Luxembourg to become carbon neutral by 2050. So it's clearly a tool that also operates in a very specific regional context. It considers a lot of different factors and is thus multivariate. And it tries to model the system in a holistic way. And similar in a way to the previous project in Grasburg, also this is pixelated. It's very similar also to the old Regionmaker in the way that it assumes a single land use for every cell. It's scalable, like you can increase and decrease resolution. And it tries to imagine like a future, how can we get to this point of becoming carbon neutral, but also to model like what would be the impact of not changing anything. These are the visualizations of the team, and basically at the center of this, it's not a proposal for a tool, it's a proposal for a project and a strategy for the country. But at the center of that project, again, is a tool. It's a monitor. No, it's a monitor that allows you to quantify the impact of any design decision different stakeholders will take in the process. Yeah. And I guess like maybe just generally to show like I guess that any tool needs a form of a taxonomy or a form of an idea of how to model and divide the world. In our case, I guess in many cases these are rather simplistic urban area, mobility, water, energy, agriculture, and forest as main categories, which then have subcategories for the quantification. And I guess this is an output that you can then see that gets modeled or quantified by this monitor, where we can see that if you continue to develop things as they go, 13.8 times Luxembourg would be the result. If you then follow the strategies that are proposed, you can shrink that footprint radically. How are we time-wise? Should we still? It's okay?
Yeah, we should.
I think we just have
finish,
one more, this one, and then the next one, the last one we'll skip. Planet Painter, again, different collaboration. There was a very speculative project that we coordinated with computer scientist students from TU Delft, which basically had this ambition to make an interactive Earth Explorer similar to Google Earth, but one that also allows you to test design scenarios within this. This was the way the cover of it, I guess. So basically, there are a few components here, I think, which can also be useful as considerations for future RegionMaker. One, we want to make the whole planet comparable, so we rely on satellite data and remote sensing because that's pretty much the only set of information that's available for the entire planet. And the second one, we are also interested to compare the same place or evolutions over time, so also to utilize historical data of satellites. Therefore, it's in a way a histogram of the planet. And then lastly, we also include ideas of biomes and climatic regions, and that was kind of the constraints of the stack of data for the tool. And again, since we're architects and designers, the focus going from mapping towards making and towards proposition within design tools. So essentially, it's this prototype consisted out of 4 parts: out of data acquisition and collection, out of then detection, so the interpretation and analysis of that information, synthesis into new forms and new scenarios and new futures, and integration, basically to link it to other existing software in the form of GIS and QGIS specifically. So here we experimented with computer vision and neural networks, so object detection through 2 pre-trained networks and 1 that we trained ourselves. And we simplified the prototype towards 3 categories. So we were interested in detecting trees. This is actually our main office in Rotterdam. And to detecting cars and to detecting buildings or the rooftops of buildings. And we also introduced tree modifiers. We can add trees, we can swap cars, and we can greenify these rooftops. So very simple, but for a prototype of a tool, if you get that to work, of course, you could extend it to a lot more parameters in the future. And then again, linking that also to the environmental impact, which is important because if you use a tool all over the world, adding a tree will have a different impact if you do it in the Philippines than if you do it in Rotterdam. And then, of course, lastly, we want the visual feedback, but we're also interested in quantifying performance of it. And here we see some examples. So we took 2 cities to test the tool. One city center of Shanghai, if you can call it that, and the second one Rotterdam, the place that we're familiar with. And we run these detection models on it. You can see the results of that for trees, cars, and rooftops. And then evaluate statistics once we start to play with sliders and modifiers. And I think this one we'll just skip, given the time. It's another computer vision project which was more focused on machine vision and detection. So we built, okay, I'll just do it really quickly. We were commissioned for the previous manifesta in Marseille 2 years ago to do an urban study in preparation for the curators to inform them, I guess, on locations, interventions, and just to understand the city. We collaborated there with the urban department and of MVRDV, and one of the ambitions of it, there was a lot in the book. There were interviews, films, cultural analysis, and so on, but there was a large part which was an atlas. And I guess this is one thing that's maybe also interesting to consider in making these kind of region makers today compared to doing that 20 years ago, is that the accuracy of information, of course, is a lot more important. The one back then was more of a rhetorical argument, I guess, than that it had to be actually accurate. If you make such a tool today, you're also, to some extent, accountable to the data that you embed within it, which poses a big challenge in most places if you don't work in the Netherlands or in Germany, because data scarcity exists pretty much everywhere else. So in this case, we collected an atlas. The ambition was to make 1,000 maps. I don't think we got there, and to attach them to different results or statements and verify or disprove our own assumptions over Marseille. And one of these maps was a map on graffitis that we had to produce from scratch, and that we think is interesting because it allows a different method maybe to sample or to understand cities and to acquire data from them. The starting point for this was basically that people in Marseille claimed that it's a city in Europe with the highest density of graffitis, and when we asked them where they were, they had a map of 30 graffitis. So we were interested in how can we capture this, and basically developed a process to create our own map. That's a map of Marseille's graffitis, which was based on GIS, sampling Google Street View images. We built a data set of 400,000 images along the whole city. So this was a mock-up just for one district. This is the data set, or an extract of the data set. And then we pre-trained neural networks to detect graffitis within this, cropped them, made this collection, this mural, and then mapped it back onto the city. And again, also experimented, once you have that, with different forms of maps and visualizations of this information. So I think in the context of a region maker today, it's an interesting aspect to consider, like also how to capture these kind of informal or fluid data that exists in the city, and how to pair that maybe with the hard GIS data of roads, buildings, parks, and so on.